Right, we now have this example. This is still on applications of Newton's laws. This third example is on systems in acceleration, specifically in uniform circular motion. And so we have here a racetrack that has the shape of an inverted cone, as shown. And so on this surface, the cars race in circles that are parallel to the ground. And so show the free body diagram of the car. B, for a speed of 34.0 meters per second, what is the radius of the circular path of the car? And at what value of the distance should the driver locate his car if he wishes to stay on a circular path without depending on friction? All right. And so first is that we are going to illustrate the free body diagram of the car. And so if we're going to recreate that, so it's like we have this one, no? And then say this is the car. Okay. And so assuming that that is the center of mass. Okay. Let us establish, wait lang. As assuming this is the central line. Ito siya. Alright? And so what do we know? What do we know first? Or what we can illustrate first? Okay? We have there, of course, we have the mass or the weight of the car. So kasi yung pinakamadali, it will always have its weight. And so say this is, and so that is the weight of the car. Right? We have there the radius. And ito yung radius natin. Let's have that as small letter R. D yung gagamitin natin. And so D is the distance from the car to dito. To the center. And then, what else? And so, if that is the car, and so of course, meron tayong normal force. And so, it's on the surface. We have the normal force. And so, nandyan yun siya. Again, normal force is perpendicular. Perpendicular to the ground. And so, nandito ngayon yung normal force natin. What else? And so, I'll just draw. Okay, and so what will be, and we have there 40 degrees, and so this is 40 degrees. This is also, and so 40 degrees. What else? And we can say, actually, this one is also 40 degrees. At the same time, this is also 40 degrees. And so for the normal force, kung titignan niyo yung normal force, as it is at a certain angle, so it will have its components. And so we have the nx and then n sub y. Okay? And so what else? Ayan. And so those are now the forces acting on the car. Alright. And so una, we are trying to solve again at we are going to solve for the radius and then the distance or the distance d. And so in this case, meron tayong dalawang unknown, and so we'll again have two equations. But then kung titignan natin yan, no, we will be able to form there parang right triangle. This is D. This is R. And that is 40 degrees. And so we will be able to solve for, and so tingnan natin kung ano yung una natin masasolve, whether that's radius or the distance. Alright? And so first, again, applying Newton's laws of motion, and the summation of all forces, and the summation of all forces along x is equal to, and so we have their mass times the acceleration. And so ano yung acceleration na yan? And so that is now towards, or that is directed towards the radius. So that is now AR. Okay? And so what are the forces acting? Ano yung forces na nag-act papunta dun sa center natin? Ito yung, ito. Ito siya ay yung R, papunta dun. Okay, so what are the forces acting on R? And so, since wala tayong friction, and it says there in the problem, without depending on friction. So basically, there's no friction on the racetrack. So we only have the component there, which is, and so we have nx times mass times, we have their acceleration. Ano yung acceleration na yan? That is v squared all over r. Okay? How can we solve for nx? And so if we're going to expand that, that is actually now n sine, and n sine theta as equals mv squared all over r. And so with that, and mayroon tayong r, we can actually keep this as equation 1 already. Okay? Next now, we determine, and so the summation of all forces, and the summation of all forces along y is now equal to, and because dito naman na ngayon, for the summation of all forces along y, it's in equilibrium. Okay? And so when we say in equilibrium, that is now equal to 0. And so what are now the forces acting along y? And so ito siya, oh. Parang dito na tayo ngayon. Sorry. We have there, here, we have f sub g, and then we also have ito. Okay? So we have, and then, and normal force along y, and so it's positive, and then we also have a minus the weight, that is equal to 0. And so if you're going to expand that, that is now n cosine theta is equal to, and so mass times acceleration due to gravity. And so isolate natin yung n, that is now mg over cosine theta. And so we keep this as equation 2. Now, if you are going to look at our first equation and then the second equation, and so we can now solve for r. Okay? We substitute the value of n in the we substitute equation 2 to equation 1. Therefore, so sulat ko muna yan, n sine theta equals mv squared all over r. Okay, substitute na natin. And so mg cosine theta, pangit. And so sine theta is equal to mv squared all over r. And so kung titignan natin to, diba? What is sine theta over cosine theta? This is actually equal to tangent. And so tangent, or we have the, and then we have m on both sides of the equation. So we can actually also cancel this one. So ang maiwan na lang sa kabila is g tan theta is equal to v squared all over r. As isolating r, we will be having there r is equal to v squared all over g tan theta. So substitute na natin kasi we have the value for the velocity, which is, 34. And 34 meters per second squared times 9.8 tangent theta, which is 40 degrees. And so we now have the radius, which is equal to, if you're going to solve for that, that is 141 meters. Okay? Since we have already the radius, and so yun na yung nauna nating na-solve, we can now solve for the distance so that the driver, locate his car if he wishes to stay on a circular path. And so from this one, no, this one, okay? And so we can actually solve for d given the value of the angle and then given the value of the other side. And so that is, and so kung gagamitin natin cosine theta, that is equal to adjacent, we have r all over d. And so solving for d, that is actually r all over cosine theta. The radius that we had, which is 141, and 141 divided by cosine 40, that is equal to 184 centimeters, 184 meters. And so there, that is now our D.